Let me open up my calculator as well. I will need it. Which one? Six.
Newton's second law.
What? Changed your mind or?
My question
second law. Question 6.
Just wait till last question.
Let's wait before this?
After.
Oh yeah, so do you still want me to do this one?
I was able to be.
You're able to do it. So
The answer is not the same.
how different is it?
Yes.
Yeah.
Are we good or not good on Newton's second law?
Very good.
Good.
Not good.
If not good, which
Okay.
number 3? The answer is wrong. Are you sure? My answer is not meter. My answer is not meter.
60.
Yeah. What's MN? Mega Newton. That is okay. Is it okay? No, this is not acceleration. This is force. I wanted force. Yeah. This here, look. Jerry. MN is 10 to the 6 newtons. What, Bruce?
Well, what is it?
Huh? Newton's second law.
Newton's second law. This paper.
The number. In Newton's second law, number 6 but C.
Yeah.
Oh, I have a problem.
Okay, we're not making much progress here. On the lesson of Newton's second law, which question do you need me to do? You said 5, you said 6. Okay, we're clear now. I will do 5 and I will do 6. So number 5 here. Newton's second law. A 5,000 kilogram tugboat is towing a 50,000 let me make that a bit bigger. 50,000 kilogram ship, and that is in the direction northeast. And this little ship here is tugging it, and that's 45 degrees.
How do you know that's 45 degrees?
Because northeast is 45 degrees.
Alright.
Always.
Oh, that's why.
Is that the only question?
Yeah, that was my question. Why that's 45?
And then a second tugboat pulls it north 10 degrees east. So there's another tugboat here. No, sorry, that's the wrong way. Here. And this angle is 10 degrees. And they each tug at 10 kilonewtons. So this tugboat has 10,000 cos 10, and this way it has 10,000 sin 10, and then the other one, the 45 degrees, is 10,000 cos 45, and the other one is 10,000 sin 45. So this is the total force north, and this is the total force east. What is the magnitude direction of the ships? Yeah, I'm sorry, I should have magnitude direction of the force. I was looking for the total force. So we have to add these together. Here we go. Okay, so 10,000 divided by root 2 plus 10,000 sine 10. So 7245 And the other one is 1 over root 2 plus cos 10 times 10,000. Yeah, 16,919. So the total force,
The horizontal force is different.
it's not this?
Yeah, it's 807.55.
Use 10,000 cos 10 on the
Yeah. 1 over root 2 plus sine 10 times 10,000. Oh, how did 8807? Okay, thanks. Is the other one right? Okay, so the angle here, the theta, is tan inverse 16919 over 8807. So it's 62.5 degrees. And that's that way. And then the magnitude of the force would be square root 16919 squared plus 8807 squared. 19074.
Teacher, northeast, is that 45 degree inside, like from north to east or here to here?
Northeast?
Yeah,
Or
the
north
45
angle
degree.
east?
No.
Are you talking about this?
No.
You're talking about this?
Yeah.
Yeah.
The 45 degree.
Yeah.
Is it inside that or outside?
Inside.
I mean, if the question says northeast,
Yeah.
then probably we have to see the 45 in downside or the outside.
But it's the same.
But yeah, it's like, I think that.
One is like north, then east. Then is it inside or outside?
North then east?
not
10 degree.
not 10 east.
Oh, like this?
Yeah. Is it then
You
inside
start at
or
the
outside?
north
Oh, okay.
and go east to the east 10 degrees. Yeah. Is
So
that?
if question mentions some degree between northeast, that I use that degree, but it doesn't mention anything, it's the 45.
If it doesn't mention a degree, it just says northeast, it's always 45. Yeah. Okay. Do you have a spare pencil or a pen or something I can borrow as I'm making notes here in case I need to change any of the answers? Is this answer okay?
Yeah.
Oh, well, no actually, because it looks like I wanted the acceleration.
Oh, and you can get it.
Yeah, well I can get it now from just using F equals ma. Oh yeah, so the question is which m to use, because you actually have 3 masses. So which m is it?
The mass of the ship.
It's just the mass of the ship. We're looking for the acceleration of the ship. Yeah. So that would mean from F equals ma, we can get a equals 19074 over 50,000. And does that work out nicely? 0.381. And I believe that is correct. Okay.
I have a question.
Yes.
When I was calculating the angle,
Yeah.
the tan inverse, I got 27.5 degrees, but that
You put the fraction in upside down.
didn't.
I'd say so. Because there's always a way I can tell, because if the student gets the answer that would make the right answer add to 90, it means they put the fraction upside down. So like if my answer was 80 and you got 10, it means I know, I can tell straight away that all you did wrong was put it in upside down. Which isn't really actually not a problem, because if you got that angle, then you would have to just say north, that angle east then, yeah. Okay, will we look at 6 now? Yeah. Children are jumping off a 2-meter wall and land on soft sand as shown. A 40 kg child jumps from rest and lands on the sand. By bending his knees, the ground slows him down over a distance of 10 centimeters. So this distance here is 10 centimeters. How fast is the child going? 2 meters. When he hits the ground. U, 0. V, don't know. A, minus 9.81. T, don't know. S is 2. And we're looking for V. So we've got V squared, is it? Yeah. V squared equals U squared plus 2A... Oh, sorry. Minus 2. 2AS. So that means V will equal... 6.26 meters per second. Did you get that?
Yeah.
Yeah. Okay. B.
A sounds like
Oh,
Oh, yeah.
it's a little wrong.
Is it a label?
Yeah, it's a little wrong. I'll fix it. It's 6.264. Okay. What is the acceleration upwards of the child when his legs are bending? So if you look at the bending part, the U is 6.264 with a minus. The V is 0. The A is what we want, the T we don't know, and the S is minus 0.1. So we're looking at the deceleration here when he's hitting the sand. Isn't that what I'm looking for? Yeah. V squared equals U squared plus 2AS. Yeah. So it is exactly 196.2. Yeah. Because I got this answer right at the back, it means the previous answer... Oh, it means the previous answer I just mistyped. What is the net force upwards on the child when his legs are bending? So this is just F equals MA. 7848 newtons. Now, because we have already done weight and reaction force, we can actually do the optional parts now of D and E. So if you look here, sorry, can I scroll down or do you need a minute? Are you sure? Yeah.
He dropped down.
Yeah.
The acceleration is 9.81.
Correct.
It's not minus because down.
No, down is minus 9.81.
Down is minus.
Yeah.
And up is
positive.
Oh.
So that's why this is a positive here, because it's upwards when he hits the ground. You see how it's very big because it is a short distance. No? Is it okay? Are you sure? You don't look okay.
Not really. What does that mean?
Because last time that is because gravity is always up and down.
Yeah, correct. Correct. This is not gravity though. This 196.2 is coming from the ground.
Okay.
The ground pushing him up as he hits it, slowing him down, giving him an upward acceleration. So he's fallen, it's 9.81 minus. So he's fallen, and then when he hits the ground, he slows down. This is upward 196.2. See how big a difference that is? 9.81 and then 196.2 upwards. Is it okay? You look so worried. If you don't understand, you can ask me.
throw the ball up,
Yeah,
also
minus, yeah.
So it's always minus.
Always minus.
Or
Yeah.
From time.
From gravity. This is not from gravity, this is from the ground. Yeah. Can I do the optional part D and E? Yeah? I don't know if anyone tried it, D and E.
No.
No. So let's have a look. Now you should be able to tell me, what are the two forces acting on him? Look, there he is, landing.
Wow.
We'll just have some, I don't know. Anyways, what are the two forces acting on him when he is on the ground, when he makes contact with the ground, when he's touching the ground? What are the two forces on him?
Weight and drag.
Weight,
Drag.
which is 40G, yeah?
Yeah.
And what else?
Drag.
Reaction, very good, Jerry, thank you.
Oh.
Reaction. 7848. Which one's that?
Yeah.
No.
Three.
No.
No.
Neither of those.
Pardon?
This. Which is it?
The total.
It's the total. Because remember, this is the net force. So we could say 7848 equals what?
40G plus R.
Yeah, or rather I'll say or minus 40G because I want this to be a positive since this is acting up. The or is bigger than 40G. Why is the or bigger than 40G? Because it's slowing them down. Okay. And the last part is, what force is the ground exerting on the child? So which force is that? The reaction force. So the final part is, what is the reaction force? So that's 7848 plus 40G. 8240 newtons. Yeah. Now, just to put a context onto that, a scale onto that, this force, 8,240 newtons, is the same force as a weight of 840 kilograms. In other words, what you're saying is, when the boy hits the ground, it's like there is a weight of 840 kilograms on his legs now. So just to draw a comparison, this oar here, it would be like, imagine he's lying on the ground and his legs are up here, and this is 840 kg. Yeah. Now that's a lot, but the good thing is, I suppose, he's not experienced that he is not experiencing that force for a long time. He's only experiencing that force while he's decelerating, while he's in contact with the sand decelerating. Because once he comes to rest, what will happen to the oar? Not zero?
No.
It will equal 40G. So that would make it like this then. His legs are just supporting 40 kilograms, which makes sense. It's supporting his own weight. Yeah. So it's a big difference. I didn't ask you for the time, but just very quickly, let's see how long he has to bear this weight for. V equals U plus AT. V is 0. 6.264 divided by 196.2. So the good news is he only has to bear it for, that's a milli, 32 milliseconds. So for 32 milliseconds, it's like he is trying to hold this weight, his mass with his legs. Yeah. Okay, this is an interesting question, a bit tricky, but I hope it's okay now. Right, so now, next,
Wait.
weight.
Number six.
There isn't a number
Don't
six.
have
Number
2F.
2F, yeah. The
2F. So of course I have to do 2A to E to get to 2F, which is no problem, what about 3 and 4?
Yeah, 3 and 4.
I don't understand that sentence. What about 3 and 4?
Oh, it's 3 just explain why.
Okay.
Yeah.
Okay, so we'll do 2. Right, let's have a look at 2.
4 is okay though.
4 is okay? Alright.
So we
But
can
that's
do
first, yeah.
You want to do 3 and 4? Okie dokie. No
2
problem. Wait.
And the next paper 1 to 6.
Yes.
No.
1 to 6 for real?
No, next one.
Okay. Number 2. A gun fires a 42-gram bullet vertically upwards with a speed of 256 meters per second, and it's 0.042 kilograms. Ignoring the drag, how long should it take to reach its maximum height? So it should take UVATS 256, 0, minus 9.81, and I'm looking for the T, so what is the, just V equals U plus AT. So the T is 256 divided by 9.81. Is that all right?
Yeah.
26.1 about seconds. Now, it won't take that long in real life. Will it take longer or shorter to reach the maximum height?
Shorter.
Shorter.
Because there is drag.
Yeah. The drag is going to slow it down quicker. In other words, the question is, will it go to rest quicker or not? Quicker, yeah, because you have an additional force slowing it down. Okay, so it should take 26 seconds, but in part B I told you it actually took 18 seconds. What was the real deceleration rate? Okay, so this time U is 256, B 0 still, A we don't know, T is 18, and S we don't know. Yeah. So we have 0 equals 256 plus 18T.
18A.
18A, of course. 14.2 minus. Okay? Now, I know for later in the question I might need to know the S, so I might as well get the S now.
What?
I might need it for later.
Oh.
Yeah. So S equals UT plus a half A times 18 squared. So 2304 meters. Okay. Continue. What was the net force acting on the bullet? Okay, well that's just good old F equals ma. So 14.2 times 42 grams, 0.597 newtons.
Do we need to subtract the weight?
Not in part C, because I said the net force, which means the total force.
Oh, okay.
But in part D, I want the drag. So if we look at the bullet, there's two forces on it, the weight and the drag. And these both add together to make 0.597. So then the drag will be 0.597 minus mg. So 0.185 newtons. is the drag force. Yeah. E, when the bullet reaches its maximum height, it begins to fall and reaches a terminal velocity of 25.6. How long until it reaches this velocity? Okay, so now the bullet starts at rest and it finishes at 25.6. The A we don't know for certain yet, and the T and the S we don't know. We could work out the A, because what's happening with the bullet, as it falls, it still has its weight of 0.042, 9.81, but it has a drag of 0.185 newtons. So the force downwards is 0.042 times 9.81 minus 0.185, 0.227, and that's down. So that means the acceleration is minus 5.4.
Minus.
Because it's down. It's accelerating. It's falling. And actually, technically, really, I should also say the V is a minus 25.6 because it's heading down. This is all downwards. Yeah. Let's get the T and the S here by using V squared equals U squared plus 2A S 8S. Yeah, okay, so S 25.6 squared divided by 10.8 with a minus 60.68. Woohoo. Meters. And finally the T, I'll just get that with V equals U plus AT. So V equals U plus AT. 4.74. F, what was the total time for the flight? Okay, so let's recap our picture so far. In the first part, the bullet is fired up to a maximum height. This took 18 seconds and it travelled 2,304 meters. In the second part of the story, it continues to fall back down. It reaches a terminal velocity of 25.6 meters per second. It took 4.74 seconds to do this, and it fell a distance of 60.68 meters. For the last part, it's moving at this constant velocity here. So this last time, for this last part, would just be the distance over the speed. But what is the distance? Well, the distance would be 2304 minus 60.68. Because we know this and we know this, and we're looking for this part. So that's 2304 minus 60.68 divided by 25.6. So that time is 87.63 seconds. So the total time is that plus 4.74, yeah, plus 18. 110 seconds for the total. Boom. This is a difficult question because there's lots of parts to it. Yeah?
So it reaches 25.6 and then remain constant
Yeah.
for the rest?
Yeah.
But how is that possible? Because we have acceleration acting downwards, right? So it has to be like every 10 seconds, every 1 second increasing.
Yeah, you see, the problem is we're treating the drag as if it's constant. But it's not really constant, it's changing. So in fact, as it falls, this is increasing. Yeah, and terminal velocity is when the drag equals the weight. I know what you're saying. It is accelerating downwards, but really it's a bit of a cheat here because this is going to decrease to 0 as the drag increases to match this. But it's way too difficult to consider this increasing. So that's why in the question I told you what the terminal velocity is. Because it will be too difficult otherwise.
Teacher,
Yes.
what if the gun is shooting downwards? How about the acceleration of the gravity? Is it negative or positive?
It's still negative if it's shooting down, but it will have minus 9.81 plus the drag force because the air is acting up. Everybody's freaking out about the signs. The sign is only to tell me the direction. That's all. Or the acceleration or the velocity. Yeah. Why are you so unhappy about this? I know why you're so unhappy about this, because probably in school you did it as positive. Yeah. But I said it's not a problem to call down positive as long as you call up negative. It's totally fine. It's just a matter of your preference. Are we looking at a tree here?
Teacher,
Yes.
how do we know the bullet fall to the same position as it fired?
Because everything is just moving vertically here. Even though I didn't draw it like that, it's just going straight up and down.
Okay.
Yeah. It's the next lesson where we consider the angle. Okay, are we looking at number 3 next on this one? Is Chrissy, yeah?
Actually, okay.
No, I'll do number 3.
The explanation.
Yeah, we look at number 3. A 1200 kg car will accelerate to its top speed of 160 kilometers per hour. And this took 20 seconds. What was the approximate average drag force? Did I misread it? And thrust, yeah, okay. Okay, so let's work out the acceleration. UVATS. U0, V, I need to convert it. A, I don't know. T is 20, S, I don't know. So 160 kilometers, and then, okay. Okay. So the A is,
2.22.
yeah. 2.22, okay. So that means the force is...
Is that the net force?
The net force, yep. Yep. This is the net force. This is the net force. Because F equals ma is always the net force. Yeah. Now, this is the net force. What's happening here is you have a driving force at the beginning, which we call thrust, which is T, and we have a drag force at the beginning, which we'll call 0. Then at the end, you still have the same thrust, because it's the same car with the same engine. But what's different now? You have a drag force, and this drag force will equal the thrust in this picture. Yeah?
Yep.
And in this picture here, the T is obviously bigger than the 0.
Yep.
But what about, where does this come into it? Well, this is the average total force. So let me draw the car in the middle, somewhere between the start and somewhere between the end. This is still t, but this will be 0 plus d over 2, because it changes. It's an average. No, I see confusion. I feel confusion. Yes? You're okay with this? You look so confused.
Yeah, but why don't we do this during the bullet plate or like going up and down?
Yeah, I should really be... the difference is, in the bullet question, the force, although I didn't say it, that drag force is always a drag force, an average drag force. What's different about this problem is that I'm only giving you information that tells you the drag force at the end.
And the beginning.
And the beginning. I'm not giving you information like how I did in the bullet that would tell you what the average drag force was throughout the journey. It's like I've only told you the ends of the story, not the drag force throughout the story. So if I know the end and the start, I can know that this is the average. So the total force will be T minus D over 2, which is supposed to be 2667. Yeah? But we know what D equals. What does D equal?
D equals to T?
Yeah, so this is equal to T over 2, because this is a T. Yeah?
Oh.
So that means I can know the T. It's twice this number. 5,333 newtons. And now I can know the drag force. It's 0 plus D over 2. And remember we said D equals T. So if I do plus 0, obviously the same thing, divided by 2. And I'll get the drag force is 2,667 newtons is the average drag. How's that one now? A couple of people were looking
I
at
don't get it. Why is T minus D over 2 equal to T over 2?
Because I said this. So T minus D over 2 equals T minus T over 2, which is 1T minus a half T, which is a half T.
Okay.
Is it okay? You're not convincing me. Is it okay, Christy? Yeah. Good?
Is there any friction than that?
No, both. Fine.
Because yesterday, IST class we learned friction, physical path, and the physics.
Yeah. We use both words. There's a small difference. But really friction and drag, they're synonyms. I think friction, the slight difference is friction is a bit more of a general term. Drag usually refers to an air friction.
Drag?
Okay. Projectiles. 3, I figured. 3B.
Number 4? I mean,
Number
weight
4.
and drag number 4.
Weight and drag number 4. Back to weight and drag. Okay. Don't guilt trip him. If he wants to ask number 4, he can.
No, it's just a minor question actually.
Okay, what's your minor question then?
Because at my last part, f equal to 0.1 times 9.81 minus d
Yeah.
equal to ma, and then the a I'm using negative. But back to the question number 1, the skydiver one, the a that you show us is positive, is it?
In my answer on the video,
Oh, it's a positive? What? Oh yeah. No. In this question is positive and in 1b is negative. The
Yeah. did I? Okay, well that's fine. I would have done, like, if I did that, I must have thought of calling down positive. Tell me what I said its speed was in the question. Did I go with v equals 56 or minus 56?
Which question?
Number 1.
Number 1b.
Yeah.
It's a skydiver.
Yeah.
50 kg skydiver.
Yeah, but in my workings, in my video.
I didn't check out of it.
So where are you getting the A positive?
What?
Because we checked with the answer and the answer showed that A should be positive only we get the correct answer.
If you work out A is positive, you get answer.
But if you work out negative you get...
Wait, hang on, I'm very confused. What's the problem here? Are we talking about A, B, or C?
Number 4.
Number 4.
Oh, we're back to 4. Okay. Right. What's the problem with number 4 then?
The last part, which is W minus D equal to MA. I'm not sure whether the A should be positive or negative.
W minus M. W minus what?
D.
D.
Drag
Yeah.
equal MA.
Yeah. Okay. So you have W minus drag equals MA. And here the W is bigger than the D. The A is a positive.
Is a positive?
Yeah. Now, it's only positive in the formula. In the diagram, you would say the acceleration is upwards. Hang on, I can't sure. Is it slowing down when it falls?
Fall down.
No, it's falling down, sorry. Oh, the A is negative, yeah. The A is negative in the picture. It's like minus whatever, 2 meters per second squared. But that's... Okay. Just a little bit of algebra. Watch this carefully. If I say this is, I don't know, 5 newtons, and this is 6 newtons, what's the total force? 1 newton down. Or if you write it as this form, it's minus 1 newton. Okay? So if I went with this, I have MA equals minus 1, so I get A is a negative because it's heading this way. So basically I'm saying 5 minus 6 equals MA, which makes A a negative. But I can think about it like this. I could say 6 minus 5 will equal the force down, and I can call this a positive because I know it's down. I know it's confusing. You actually have a lot of flexibility with the signs. I can say the force is 1 newton as long as I remember it's down, and when I draw it down. If I didn't know it was down and I got F equals minus 1 newton, then I'm told it's down. But I can replace that by saying 1 newton down. Yeah. I know it's confusing, but you need to be able to, in your head, switch between me saying F equals minus 1 newton, or if I say 1 newton downwards. Because remember, the only purpose, what's the only purpose of the sign?
To
Show direction, which I achieve by just saying it beside it. Or I achieve it by drawing it like this. I don't have to do this because I know it's already down. Yeah, so this is the key issue here, is it, for number?
No, so in this case
Oh my
it should
goodness.
be negative, right? Because it is going down. The A.
Yeah, but I can work it out as a positive as long as I keep track and remember it's pointing downwards.
But because I'm using weight minus D, so
Yep.
the weight is bigger than
Correct,
D,
yeah.
so the A should be negative. But the answer given, if the A is negative, we get incorrect answer. We can only get A as a positive in order to get correct answer.
Yeah, look,
But
here, if you say weight minus drag equals MA,
yeah,
this will work out to be A as a positive, because the W will be bigger than the D.
yeah.
Like, let's say this is 6 newtons, and the drag is 1 newton. So you get 5 newtons equals, whatever, 1 kilogram multiply A. So A is a positive. In the formula, but I know it's downwards, so I need to keep track that this is downwards. So my answer would be A equals 5 meters per second squared down, or A equals minus 5 meters per second squared.
So in short, the negative should not affect the calculation, because if you use it as negative and you take you take W minus MA is equals D, and if you use your A as negative, that will change the answer.
Oh, okay, so in this question you know the A, is it?
You know M,
You,
you know W.
and you know the W.
They're looking for.
Yeah. So if you want to play it safe, you should say it like this: D minus W equals MA, where the A you put in as a negative. And why am I saying D minus W? Because the D is the positive and the W is the negative. To be even more precise, it's like this: F is the total F, correct? Which is the up plus the down, which is D plus minus W, the minus indicating the down, which is D minus W, which is MA. Yeah?
Yeah, I get this. Then what about 1B? Because the skydiver is going down, so the weight should be bigger than the drag. But in our equation, I think you show us this, right? I forgot the skydiver B.
Yeah?
And then the A you are using negative, but the weight should be bigger than D, so the A should be positive.
The weight is bigger than D.
So
Correct.
the A should be positive, right?
No, the A is negative. If the weight is bigger than the drag, he's heading down.
And we use W minus D.
Then if we use W minus D, we'll use the A as positive.
Yeah, but we are using A as negative.
Then we should use D minus W.
But no, we are using W minus D.
I don't think you're getting what I'm saying, which means I'm not saying it well. You can use either of these.
Yeah.
If you use W minus D or D minus W, that affects the sign. If you say D minus W, that makes the A negative. If you say W minus D, that makes the A positive. Yo, dude, which is it, W minus D or D minus W?
W minus D.
And did I say A is positive?
No, A is negative in 1B.
Did I say it at the end or in my calculations?
In the calculation.
Well, then that might be a problem. Oh, I better do 1B then.
Yeah.
Did people get the same answer at the back?
Yeah.
Did they get it because they made the same mistake as me, or because they did it right?
Do you use A positive or not?
Okay, I'll do it. Well, listen, hey, dude, I'm doing it now. You have your wish. I'm doing it.
Okay.
All right. Okay. And I will be super clear with the signs.
Okay.
All right. So, U 0, B equals minus 56. A equals minus 9.81. T we don't know, S we don't know, but I know it'll be negative. Right, and what do I want first? The T.
Yeah.
V equals U plus AT. Okay, what's the T here then?
5.708.
What is it?
5.708.
5.708 seconds. And the S, do I need to know it?
Mm.
No. The skydiver opens his parachute. Beautiful. And it produces a drag force. As such, he slows down. Oh, so in this one, the acceleration is upwards. Yeah, because he's slowing down. He pulled open the parachute and the parachute's pulling him back. So here, what am I looking for? The drag force. So I'll get the acceleration. The U equals what? Minus 56 if we're being careful. The V, minus 1. The A, we don't know. The T, 6. Yeah. The S, we don't know. And let's get the A. V squared equals U squared. No. V equals U plus 6A. So that is 55 over 6. What's that? 9.17 meters per second squared. Positive. So this is telling me that the force, the net force, the total F is a positive because the A is a positive. So this might feel strange because he's still falling. How can he still be falling if the force in total is upwards? Because although he's still falling, he is reducing his speed. So it's like there's a brake, a backwards force trying to slow him down. Will this force continue forever? No, because if it did, then he would start rising back upwards to the plane. Which he doesn't. So the A here, yes, is definitely a positive. So the answer is fine.
Yeah.
You need to sleep on this. You need to go home. You need to meditate. You need. Yeah, I think so. Yeah, we need time to reflect on this new information. Then, okay. So when we come back, then I take it we're going to look at projectiles.
And
The rockets.
and
Okay. All right. Fine.